Hey everybody, Mr. Vels here. This is for section 2-6 of Precalc A. This is on rational functions and their graphs. Sorry, I didn't get the camera shot up. So, rational functions and their graphs. So what happens when we have x's upstairs and downstairs in a fraction? We get vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, wholes. We're going to talk about limits. So what happens? Does the graph go up? Does the graph go down when we approach certain numbers if we can't have it equal those numbers? Okay, so stuff like zeros in the denominator when we have those issues. You should have seen some of this stuff before. We're just going to maybe extend it and do a few other things, even some So we're going to start with this whole limit-y things here. So what's the limit of a function as x approaches some number? So we're going to take this thing right here, 1 over x squared plus 7x plus 12, and I'm just going to talk about it mathematically speaking. So let's say right now x approaches infinity. So I want to do this one right here. So x approaches infinity. And remember, you guys can pause the video, stop it, copy any of this stuff down that you need to. So when x approaches infinity, that means the x is getting really big. So like in the quintillions, right? So this is 1 divided by a quintillion squared. So if I take one, like say one cookie, and split it up among quintillions of people squared, pretty much means that the function is going to get closer and closer to 0. So as x gets really big, if you have 1 divided by lots and lots of stuff, the average person is not going to get much of anything, maybe a thing. So again, it doesn't equal 0. The limit of the function is 0. It will actually still be a number, but it would be like 1 divided by something. So it would be like 0.000000000000000, a lot of zeros and a 1. So the function's limit is 0, which means, yes, you'll have an asymptote there. Okay, so what about here? What does this mean? Well, -3. So let's try -3 in here. So -3 squared is 9. 9 and 12 is 21. -3 times 7 is -21. So 21 and -21 equals 0. Oh, division by 0. So we can't let x equal -3. That's impossible in this problem. So what about as x gets closer to -3? Well, then we have to decide, does it get closer to -3 from the right side or from the left side? So when I put a little negative sign, that means it's getting closer and closer to -3. Right? 1, 2, 3. There's a vertical asymptote right there. It can't equal -3. When I put a little negative sign, that means it's getting closer and closer to it from this side. When I put a little positive sign, that means it's getting closer and closer to it from this side. And I do it mathematically first so that you guys can see it. So what's a number that's really close to -3, but not -3? So like I could use -4. So -4 squared is 16. 16 and 12 is 28. And -4 times 7. Ooh, did I just do that right? Oh my gosh. Look, I can't use -4. It's also going to be an issue, -4. Let's try -2. That was bad. -2 squared is 4, and 12 is 16, and -2 times 7 is -14. So 16, -14, +2. Okay, so that means when I'm, -2 is right here. So, okay. So that means when I'm getting closer to it here, it's going to be a positive number, which means that it's probably going to look something like that. If I show you a -4 here also, -4 is going to have an asymptote. Let me go ahead and give you the graph, and then I'm going to explain the algebra again if you guys didn't already know that. So y equals, clear a big polynomial. So 1 divided by parentheses x squared plus 7x plus 12. Okay? Poof. And you can see that there are asymptotes at both of those places. Now what we just showed you was at -2, and if I go to trace here, at -2 that number was positive, right? And you can see, so as I approach, if I get closer to negative 3 from the right-hand side, or from the positive side, I head towards infinity. However, if I keep going this way, you can see that as I approach negative 3 from the left-hand side, it's going to go down. It's going to go down, okay? So negative 3 from the left-hand side, since the graph looks like this, right? The graph looks like this, and like this. And I approach negative 3 from the negative side, that's from here. It's going to go down, so it's going to head towards negative infinity. When I approach negative 3 from the positive side, that's this way, right? From the positive side, that's going to head towards positive infinity. And when I head towards negative 4, do you see how, well, if I come from this way, it goes up. When I come from this way, it goes down. So I can't, my point is I can't just leave it like that, because there are two choices, A and B. And that's why we have to have those little minus signs or plus signs. So I could pick any one of them. I'm going to go ahead and say from the positive side. So again, that's from the right heading towards negative 4, getting closer and closer to this line. And you can see that it goes down. So that heads towards negative infinity. So that's kind of a little description about asymptotes and limits as you approach things that can't work. So bigger picture, why does negative 3 and negative 4 do this? Well, if you take your original thing right here and take that denominator, you can see that that factors into x plus 3 and x plus 4, which means at negative 3 I would get a 0 in the denominator, and at negative 4 I would get a 0 in the denominator. And I can't have zeros in the denominator. Zeros in the denominator give me vertical asymptotes. Okay, so that means now, hopefully that worked for you guys. If I give you a graph like this and I say, hey, if this is a graph, what could a potential equation be? And if I said, how about this? F of x equals 4 over x minus 7. You would hopefully say, no, that can't be that. That can't be that, because this would have to have a vertical asymptote at 7, right? And this doesn't have a vertical asymptote over here at 7. This has a vertical asymptote over here at 3. So that doesn't work. But f of x equals, say, 3 over x minus 3. That could work. Could work. Now, these things could go out here further and further and further, but still have these asymptotes at 3. So the bigger the number here, the further out these things are going to go. They're still going to have, again, they're going to get closer and closer to that line, but the further out they're going to be before they get there. Now, if this number was a negative, then the graphs would actually go here and here. Good deal. So positive number, first and third quadrant type situations. Negative number, second and fourth quadrant. I think we've covered that stuff enough before, but just hopefully that's good. Okay, so now I'm going to do this. I'm going to try and graph this thing without a calculator. See if I can get a whole bunch of information from this particular equation. So one of the first things I do, you guys know this, we've done this before, right? If I want to graph it, horizontal asymptotes are good to know, vertical asymptotes are good to know, x-ints are good to know, y-intercepts are good to know, right? And holes are good to know. Any of those things help us understand what's going on with this equation. So let's start one of the easy ones first. Let's start the y-intercept. The y-intercept is at 0, negative 1/7, right? Because I plug 0 in for all those things. Horizontal asymptote, that's this one right here. That's at y equals 0 because the x squared grows at a faster rate than the x, so that means you'll have a small thing divided by a large thing. So I know I have that. So let's come over here and see if I can get some of this information on here so far. So I know that I have a horizontal asymptote at y equals 0. So, right there on top of that line. Let me do that. So that's kind of dashed. I have a y-intercept at 0, negative 1/7, so if this is 1, negative 1/7, it's like right there. But I don't have much else at this point in time. So I have to break it apart. So this is x plus 7, right, and x minus 2. So right here, you see I have an x plus 2 upstairs and x minus 2 downstairs. So they're close to having a hole, but they're not the same, so there's no holes in this particular function, which means both of those places have to be vertical asymptotes. So I'm going to come over here to negative 7. 1, 2, 3, 4, 5, 6, 7. The vertical asymptote there, and at positive 2, 1, 2. There's another thing. So now I have a big like H with a split through it. So I'm going to have a horizontal asymptote here and vertical asymptotes here and here. Vertical asymptote, what do we have there? X equals negative 7 and x equals 2. Right, now let's see if I can find an x-intercept. X-intercept occurs at the zeros of the numerator right here. So that's at negative 2, 0. So negative 2 comma 0. So I go to negative 2, and I know that that must be true. Sweet. So now, can I kind of graph this stuff out? Can I kind of learn some things about this function? Well, here's the deal. So hopefully this makes sense. I'm going to do this in green. It has to touch here and here, right? And this is an asymptote. So that means that my curve has to touch, or come closer and closer to this, and go through this point, and then go through this point. Well, if it goes through there, it either is going to touch and come straight back down, or it's going to curve up. So I could try something really quick. I could try like negative 6 here, and negative 6 plus 2 is a negative number. Okay, and I just care if it's going to be above or below. So if it's below, the result's going to be negative. If it's above, the result's going to be positive. So I know in the numerator it's negative. Then negative 6 into here, that's going to be a positive number. Negative 6 into here is a negative number. So a negative, and a positive make a positive number. So that means the graph's got to go like that. So that's what's happening on the inside there. Good deal, because it's got to be an asymptote. And I just think I showed you. I plugged it into each one of these factors, and I got a result of a negative, a positive, and a negative. And a negative divided by a negative is positive number. So by negative 6, it has to be a positive, which means it has to be above the x-axis. Over here, I know it's either going to curl in here or it's going to curl in here. So I check those two things. So this is 2, right? So that's 3, 4, 5. So let's just try 5. Plug 5 into here, and that's a positive. I plug 5 into there, and that's a positive. Plug 5 into there, and that's a positive. So at 5, all of the things are positive, which means my graph has to go like this, and that sucker. And now I check over here, and this is, right, 1, 2, 3, 4, 5, 6. That was 7. So negative 8, negative 9, negative 10. Let's check at negative 10 and see if it's either up or down. So when I check negative 10, over here, negative 10 and into that, that's going to be a negative number, right? Negative 10 into this, that's going to be a negative number. And negative 10 into this, that's going to be a negative number. The result of 3 negative numbers is a negative number, which means the graph has to look like this. Now, if I can get a picture of the graph that looks kind of like that, I can answer all kinds of information about it. But first off, I want you to know whether or not I did all this stuff right. Is all of this stuff true? Again, haven't used my calculator yet. I'm going to go ahead and pull it out here. Go to my y equals, hit clear. Parentheses, x plus 2 is my numerator, divided by parentheses, x squared plus 5x minus 14, close parentheses, zoom 6. Dang, that looks pretty much like that. Now let's check a couple things, key things here. One is it crossed through at negative 2. Well, it's kind of hard to tell if it's at negative 2 here, but if I go to my table setup and I started at negative 2, you can see that yes, that was indeed a 0. You can also see that my y-intercept is 0, negative 0.143, 0, negative 0.143. Quit 1 divided by 7. 1/7 is what we said. That's my 0.143. That was rounded. Go back to this thing. It also shows me that I have an error at 2, because that's a vertical asymptote, right? Can't have division by 0. If I scroll up here, I should have an error at -7. Vertical asymptote doesn't exist there. I feel like everything hit. That's really good. So then if I wanted to explain some things right here, I said, well, what is the function at 2 equal? You would know that that's no solution, right? It doesn't equal anything at 2. So what do? We say, what is the limit of the function f of x as x approaches 2, right? From the right-hand side, what does it equal? Or what's the limit of f of x equal as x approaches 2 from the left-hand side? And I should be able to answer either one of those with these little limit notation things. So let's first one, 2 from the right-hand side. So here's 2. I'm coming from the right-hand side. What does the graph do? Goes straight up. So this would be positive infinity. What's the limit of the function f of x equal to as x approaches 2 from the left-hand side? From the left-hand side, you can see it goes down. So that answer is negative infinity. Is that good? So hopefully that's pretty good with your asymptotes, being able to graph all the stuff that I just did right there. Reminder again, if there was a hole, we would put a hole right in that location. I think I've done that enough, and with some of the other things I don't want to make this video too long. Okay, so here we go. Find end behavior, asymptote. That's a cubic, so 2x cubed. So I'm going to put it in here first. We're going to pretend like we had this. I'm going to show you how we're going to get what we get here from without a calculator. So here we go. So parentheses 2x raised to the third minus 6x plus 8, close parentheses, divided by parentheses, x plus 3, close parentheses, and graph. And you're like, whoa, that looks pretty funky. So is there first more going on to this? So zoom out, enter. Good deal. Zoom out, enter. Oh, look, there's something else over there. But it's so skinny I can't see it. So it looks like I want my y's to be bigger, but maybe not my x's. So x's, let's stick in the -15 to 15 range. And my y's, I'm going to go negative 200 to 200 range. So if you could change those right now, you can see this. I hit graph. And you can see, man, there's a little bit more stuff going on. In fact, let's go y max up to 400. And it looks like as x gets really, really big, it's kind of following a curve. And as x gets really, really small, heading towards negative infinity, kind of follows a curve there. In fact, that curve might even be a parabola. So the end behaviors of this function, there's not horizontal asymptotes, right? And they don't go like a line. This one actually follows a parabolic curve for its end behavior asymptote. Now, algebraically, how do I get this? Where does that come from? Well, this is kind of interesting, but it actually comes through just doing this division. We're going to find out what this equals when we do this. Now, we could do x plus 3 into 2x cubed plus 0x squared minus 6x plus 8, and do polynomial long division, which we've practiced before. But since this is just a linear term, we could also do synthetic division to do this division with, what's that, a 2, a 0, a -6, and an 8. Remember, we got to put the placeholder in because there's no quadratic term, there's no x squared term. So I'm going to do this actually both ways, and we'll see. So how many times does x go into 2x cubed? You know it goes into x squared times 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. Subtract, poof, -6x squared minus 6x plus 8. How many times does x go into negative 6x squared? It goes in negative 6x times. Negative 6x times x is negative 6x squared. Negative 6x times 3 is negative 18x. Change the signs, right? That's what happens when we do subtraction. That goes poof, and that's 12x plus 8. How many times does x go into 12x? Well, it goes in 12 times. 12 times x is 12. X, 12 times 3 is 36. And I subtract. 12x minus 12x, poof, 8 minus 36 is negative 24. So, according to this, 2x squared minus 6x plus 12 plus negative 24 over x plus 3 is the division answer to this, right? But if I'm talking about heading towards infinities, right, the end behavior heading towards infinities, you agree that when I head towards infinities, this fraction, this leftover remainder stuff, is going to head towards 0, which means the net result is just this polynomial right here, 2x squared minus 6x plus 12. Now watch. On y equals 2x squared minus 6x plus 12, I'm doing this in red, watch, hit graph, and you can see that the end behavior of my big funky thing follows exactly the polynomial I got through long division. Now, remember, we said we could also do the synthetic division because that's an x plus 3. So let's see if we get the same thing. Drop the 2 down. 2 times negative 3 is negative 6. 0 and negative 6 is negative 6. Negative 3 times negative 6 is 18. 18 and negative 6 is positive 12. Negative 3 and 12 is negative 36. Negative 36 and 8 is negative 24. Therefore, this is my remainder, right? This is my constant. This is my linear. This is my quadratic. 2x squared minus 6x plus 12 plus the remainder, negative 24 over x plus 3. I got the same things. Yes. That is my end behavior asymptote. Okay, so one more time. How do I get end behavior asymptotes? I do long division. So this is what I'd like you to do. Why don't you try this one on your own without technology. Find it all. See what you get. I'm going to pause the video for a little bit. 4, 3, 2, 1. Okay, we're back live again. Here, I'm going to show you all the stuff. Hopefully your stuff look like this stuff. Ha. Ba. X int. Y int. Holes. And our graphs and everything about it. So first off, horizontal asymptote x squared over x squared means I have y equals 1. There's 1. I have horizontal asymptote right there. Next, y-intercept is at 0, comma 12 divided by negative 4 is negative 3. 0, negative 3. 1, 2, 3. Got a point right there. The other things I can't do until I factor it. So here we go. Let's do some factoring. So top one, x plus 6 and x plus 2. Looks like that. Bottom one, x plus 2 and x minus 2. Ooh, look at that. Look at that. Poof, there's a hole. Hole at x equals negative 2. I'm not going to put that on my graph yet. I'll deal with that in just a second. Vertical asymptote. Vertical asymptote at x equals positive 2. Right there. That's my vertical asymptote. Or the thing that tells me my vertical asymptote. So I go to positive 2. 1, 2. Yep. I know it crosses the x-axis at positive or negative 6. My x-intercept is negative 6, 0. So I come over here. 1, 2, 3, 4, 5, 6. Touches right there. Yeah. So what I got going on here? Right, that's plus 6, so minus 6. That was x plus 2, x plus 2. Yeah, I'm feeling pretty good. So if it doesn't touch the x-axis any place over here, are you guys with me? It doesn't touch the x-axis any place over here. That means the graph has to be up into this region, yeah? And because it touches right there, the graph has to be up here coming down like this, yes, because that's my y-intercept. However, we know that it touches here and then goes there, so it must be, and sometimes this happens, must be that it comes down here like this and goes through. Oh my gosh, that's just crap. What am I doing? Negative 3. I was thinking that couldn't happen. My y-intercept's negative 3. And it goes like this. That makes so much more sense. It goes like this. I got some dims going on there, right? I was like, whoa, that didn't make any sense. How could it come down and then pop back up again without touching it? Now, just to be clear, it is possible for a line to cross a horizontal asymptote. It just can't cross the horizontal asymptote as we head towards infinities. But it can cross it early on with the other stuff that's going on with this stuff. Okay? So, according to this is what it looks like. Now I just got to put a hole at negative 2. So that means right here at negative 2, there's a hole. So follow your graph until you get to an x value of negative 2. Put the little hole in there. Now let's check and see if all this stuff that I just said is really true. So parentheses x squared plus 8x plus 12, close parentheses, down, parentheses, x squared minus 4, close parentheses, and, oh, sorry, I hit divide, I hit the down arrow, division, parentheses, x squared minus 4, close parentheses, and graph. Oops, sorry. One more here, zoom 6. So does that look just like that? You're like, yeah, that looks pretty good. Sorry about that. That's a little sunshade on it. I'm going to check a couple things. I'm going to check the y-intercept, negative 3. So table setup, yep, negative 3. Yeah. Y-intercept, where is it? X is 0, gives me negative 3. There we go. See that? Now I'm supposed to have vertical asymptotes at 2 and at negative 2, right? I only have it at positive 2. Why is it not there? Well, that's because it's a hole right there. Do we see that? So I still get an error at that point. However, it doesn't look like there's an issue because it looks like it goes straight through. However, let me show you on this one right here. So that's at negative 2. So let's do an x min of negative 2.1. and an x max of negative 1.9, and hit graph. You can see it right there. There's a missing pixel. There's an issue right there. If I was to continue to zoom in on that, I could also show you why it looks kind of funky around that spot. But there we go. There's my hole. So hopefully this was good for you guys. This is Precalc A 2-6 on graphs of rationals and limits of functions and what happens when things approach things. I will talk to you later. Thanks for watching.